These are the practice problems for lesson 11. The first two problems come directly from activity 11.3. The first question is, if two triangles have the same perimeter, do they have to be congruent? And no, they don't. So if you go back and look at that video for 11.3, we had several examples of rectangles that had the same perimeter, but were not congruent. So they had different areas, actually. Two rectangles that have the same area, but are not congruent. So it wants us to draw two rectangles that have the same area, but are not congruent. We'll just use different factor pairs of the same number. So for example, 12, draw a 3x4 rectangle and a 2x6 rectangle. They will have the same area, 12 square units, but they will have different perimeters. They will be different rectangles. But also just go back and look at activity 11.3. For question number 3, it says, decide whether or not it appears that the two shapes are congruent. Explain your reasoning. Well, it looks like it's a rotation. It looks like it's a 90-degree rotation. So actually, just in Docere, just traced the image and then rotated it 90 degrees. And it maps directly to the image on the right. So they are congruent images. They are congruent. And the next one, this is still part of question 3. This image is actually a reflection. So you translate it down and have it match. I would translate it down first and have it match. You could reflect it up here and then translate it. But I just think it's easier because you know exactly where the line of reflection is. Reflect it over. And it does match exactly. It maps to the second image. So they are congruent. So remember, a reflection, you have to, over the line of reflection, you have to move each corresponding point an equal distance and at a right angle to the other side. And so that's what happens here. And so they are congruent. In problem number 4, it says reflect this image over the x-axis and then over the y-axis. And are the quadrilaterals, it's a 4-sided figure, congruent? Well, you reflect it over the x-axis. Once again, the line of reflection has to be an equal distance on the other side, and it has to be at a right angle to that line of reflection. So the movement of those points. So reflect it over, and then reflect it over again. So here's B, and it's reflected. I didn't show you, I guess I didn't. It's reflected over, and then you're going to reflect it over the y-axis. So once again, this is the line of reflection. You're going to move each corresponding point an equal distance on the other side. So move them an equal distance on the other side. Connect the points. And it's a reflection of A to B and a reflection of B to C. And they have to be congruent. All of these images are congruent because they've gone through just a rigid transformation. A reflection. Nothing else has been done to them. But notice that if you reflect an image over the x-axis and then the y-axis, actually is a 180-degree rotation of the original image. So the center of rotation, this is not in the student manual anywhere, but the center of rotation is right there at the center is the origin. So if you connect each of the corresponding points, the center of rotation is the midpoint. And notice that each of the sides form parallel sides in the rotation because it's a 180-degree rotation. This was the point behind a lesson a couple lessons ago. About 180-degree rotation will always give you parallel sides. So this side here is parallel to this side up here is parallel to this side is parallel to this side, and this side is parallel to this side. So parallel sides, 180-degree rotation, and you can color it in. You get a nice figure. Once you color it in, use some different coloring schemes, kind of play around with it a little bit, and it's a nice image in the end. Okay, the next problem says if you move this point 90 degrees, using 0, 0 as the center of rotation, what are going to be the coordinates of the image? So this is the starting point of -2, -3. So remember a 90-degree rotation, and this is going in a counterclockwise direction. So 90-degree rotation, the coordinates are going to switch order, and one of them is going to be changed signs. So notice that if you move this point over to this side, actually if you do a reflection and move it over to here, no, they don't say a reflection, just move it over to the other side. This side now has the x-coordinate is a positive value, but the y-coordinate is still negative. So it's x is positive and y is negative. So what that tells you is that over here, this y value is going to move to the x value, but it also has to switch signs because it has to be in a positive, the x value has to be positive as you move along the x-axis. And so that tells you that the y value is going to switch to, the x value is going to switch to the y value but still be negative. So it's a +3, -2. Now to check that, you can count. So you count over 2 units and down 3 units, and then rotate 90 degrees, and count down 2 units and over 3 units. So each of those countings are rotating 90 degrees. So 1, 2, 1, 2, 3, and then rotate 90 degrees, 1, 2, 1, 2, 3. So a couple of different ways to look at this. And finally, the last problem asks you to describe a rigid transformation that takes A to B. A rigid transformation that takes A to B. And a couple ways to do it. What I chose to do, because I like looking at the rotation, since it's a 180-degree rotation, it says a rigid transformation. So I don't know if it's looking for just one or a series. So I did it in just a single rotation, but because it is a 180-degree rotation, you could also do a reflection over the x-axis like we just did in the previous problem, and then a reflection over the y-axis, and you will end up with this image. But a 180-degree rotation, remember the center of rotation is the midpoint between each of the corresponding points, and it turns out here to be 0, 0. And I like showing you guys how to do these rotations using these circles because I just think it's easier to see. So for each of the points travels on its own circle. The center of rotation has to be the same, or the center of the circles has to be the same. But they all travel on their own circles to the other side. They all travel together. They are connected. And so here that image is, and it's going to rotate around 180 degrees. And I did this once again all in Doceri. Once it's at a 180 degrees, notice that all of the sides are parallel, because that's what happens with a 180-degree rotation. So this side is parallel to this side. All the corresponding sides are parallel, and they're an equal distance from the center of rotation. So 180-degree rotation, center of rotation, the midpoint between the corresponding points, and all of those line segments, if you connect them, will intersect. And that's what we did back here. All of those lines will intersect. So 180-degree rotation. All right, practice problems for lesson 11.